Hi guys, in today's video we're going to be talking about the product rule. The product rule is a rule in differential calculus that allows you to quickly find the derivative of products of functions. Put simply, if f of x and g of x are both differentiable functions of x, then the derivative of their product is simply f dash x times g of x plus g dash x times f of x. So we take the derivative of one function and times it by the other, and then take the derivative of the other function and times it by the first function, and sum those two terms together. To prove that the product rule works, let's look at the function y equals x squared times 3x minus 4. In this case, f of x would be x squared and g of x would be 3x minus 4. This would mean that the derivatives f dash x and g dash x are 2x and 3 respectively. Plugging those into our formula, we find that y dash would be equal to 2x times 3x minus 4 plus 3 times x squared. Simplifying this gives us that the derivative y dash is equal to 9x squared minus 8x. If we go back to our original function and expand it so that we've now got a single polynomial, we can obviously go straight from our function to its derivative. And we can see again that y dash will be 9x squared minus 8x. Now you might be wondering, since it's so easy just to expand these polynomial functions and then find the derivative, why do we bother with the product rule at all? In fact, you're right, the product rule isn't really the best way to approach these kind of polynomial problems. In most cases, unless you've got many terms to deal with, it is simpler just to actually expand and then take the derivative normally. What the product rule is really powerful for, though, is dealing with other types of functions like trigonometric functions and exponentials, which we'll be learning to differentiate in a future lecture. What we're going to talk about now is the quotient rule. The quotient rule is similar to the product rule, but it deals with quotients of two functions. For two differentiable functions, f of x and g of x, the derivative of their quotient is given by f dash x times g of x minus g dash x times f of x, all divided by the square of the function g of x. To see the quotient rule in action, let's imagine we've got the function y equals 3x divided by 2x plus 4. In this case, f of x is 3x, g of x is 2x plus 4, and their derivatives are obviously 3 and 2. Substituting these into our formula and simplifying, we find that the derivative y dash is just 12 over 2x plus 4 all squared. Finally, we'll take a look at the chain rule. Essentially, the chain rule is used to differentiate functions of functions, using rules for simpler functions. The chain rule can be stated simply as the fact that dy dx can also be written as dy du times du dx. It's easiest to show how the chain rule works, so let's take a look at the function y equals 3x squared plus 5, all raised to the power of 7. Now, we have a rule for differentiating simple functions like x to the power of 7. Its derivative is 7x to the power of 6. But we don't have a rule so far that allows us to differentiate a function raised to a power. In this case, what we're going to do is make a substitution. The inner function, 3x squared plus 5, we're going to let that equal a variable u. This then means that du dx is 6x. So with our substitution, we've now got the formula y equals u to the power of 7. The chain rule says that the derivative of y in this case is going to be given by dy du multiplied by du dx. In this case, dy du is just our normal rule. It's 7 u to the power of 6. And we already know that du dx is 6x. If we substitute back into this formula the replacement that we made for u earlier, what we get is that the answer is 7 lots of 3x squared plus 5 to the power of 6 multiplied by 6x, or 42x times 3x squared plus 5 to the power of 6. What we've essentially been able to do is differentiate 3x squared plus 5 to the power of 7 as if it was a much simpler function, x to the power of 7, as long as we multiply by the derivative of that inner function. When writing these rules, it's common to use u and v in place of the two functions f of x and g of x. So our product rule becomes the derivative of u times v is u dash v plus v dash u. The derivative of the quotient u divided by v is u dash v minus v dash u all over v squared. And the derivative of v as a function of u is dv du times du dx.